The world of AI, it's just filled with all these complex terms, right? But what if we could actually break it all down into simple, understandable building blocks? Well, that's exactly what we're going to do. We're turning those buzzwords into a blueprint. So let's just dive right in.
Okay, so you've heard the alphabet soup, right? AI, ML, LLMs, generative AI. I mean, they're thrown around everywhere, and honestly, sometimes people use them like they all mean the same thing. But are they? Nope, not quite. And I promise by the end of this, you're going to know exactly how they all fit together.
All right, first up, let's get this family tree straight. We're going to define all these key terms and literally build a map so you can see how they all relate. We'll start with the biggest, most general ideas and then drill all the way down to the really specific tools that are powering today's AI revolution.
So let's start at the very top with the head of the family, artificial intelligence, or just AI. You can think of this as the big, overarching dream, the grand goal of building machines that can think, learn, and solve problems just like humans do. It's the entire field, you know? It covers everything from a robot that can play chess to a self-driving car trying to navigate a busy street. So how do we actually achieve that big goal of AI? Well, one of the most powerful ways is through something called machine learning, or ML. Think of ML as a major branch on that AI family tree. See, instead of a programmer having to write code for every single possible scenario, ML lets the machine learn the rules for itself just by looking at a ton of data. This is exactly how your email somehow knows what's spam, or how Netflix gets freakishly good at recommending your next favorite show. Okay, let's go one level deeper. Now we get to deep learning. This is a really specialized type of machine learning. It uses something called artificial neural networks, which are, you guessed it, basically inspired by our own brains. And these networks are amazing at finding super complex patterns in data. This is the real engine behind things like modern image recognition and, the advanced way your phone's digital assistant can actually understand what you're saying.
And this brings us to the term you have been hearing absolutely everywhere lately, generative AI. Now, what's interesting here is that this isn't a totally new type of learning. It's actually a really powerful application of machine learning. So while other models might, say, classify an email as spam or predict a stock price, generative AI, well, it creates. It makes brand new, totally original content. We're talking text, images, even music.
Okay, so we've got all these powerful techniques. But what's the secret sauce? What's the ingredient that has made AI, and especially generative AI, just so explosive recently? Well, it really just comes down to the sheer scale of the models we're building now. Let me introduce you to foundation models. These things are gigantic. I mean, they're machine learning models that have been trained on absolutely colossal amounts of data, basically scooped up from the internet. And by crunching through all that information, they build this really broad, general-purpose understanding of the world. And that understanding can then be tweaked and adapted for all sorts of different tasks. And of course, the most famous type of foundation model out there is the large language model, or LLM for short. And just like the name says, these are the ones specifically designed to master human language. Anytime you're talking to a chatbot or using an AI writing assistant, yep, you're talking to an LLM.
Okay, so we get what these models are now, but how do they actually, learn? Turns out there are basically three main recipes, or approaches, that machines use to chew through data. Let's break them down.
So the first two are called supervised and unsupervised learning. With supervised learning, think of yourself as a teacher. You give the model a bunch of data that's already labeled. A million pictures of cats, all neatly labeled cat. That's how it learns to spot a new cat. But with unsupervised learning, you're more like a detective. You just dump a massive pile of unlabeled data in front of the model, and its job is to find all the hidden patterns and groupings all by itself. No hints.
And that brings us to the third method, reinforcement learning. This is basically just learning by doing. It's trial and error. The model tries something out in an environment, and it gets a reward for a good move and a penalty for a bad one, over and over again. This is exactly how an AI learns to master a super complex game like Go, by playing millions of games against itself until it figures out the best strategies.
Now here's the thing. All three of these learning methods, they have one thing in common. They all need fuel. And in the world of AI, that fuel is data. I mean, without data, the most powerful models in the world are just empty shells. They can't do a thing.
So what do we even mean by data? At its core, it's just information.
But it's really important to remember it's not just numbers in a spreadsheet. It can be the text from a book, the pixels that make up a photograph, or the sound waves in an audio file. All of the stuff can be used to teach a machine.
And this information basically comes in two main flavors. First, you've got structured data. That's the neat and tidy stuff, perfectly organized in rows and columns, just like a spreadsheet. Then you have unstructured data. And that's, well, it's all the messy stuff. We're talking emails, social media posts, videos. It's way harder to analyze for sure, but that's where a huge amount of valuable insight is hiding.
But, and this is a huge but, you can't just pour any random information into your model and hope for the best. If you want to get a valuable result out, the data you put in has to be high quality. It needs to be accurate and relevant. Because if you put messy, unreliable data in, guess what? You're going to get messy, unreliable results out. It's that classic saying, garbage in, garbage out.
Okay, so we've got the concepts down, we've got the fuel, so how do we actually build one of these models? Well, it's not some single magic moment. It's actually a process, kind of like an assembly line, and it's called the machine learning lifecycle. This whole process really boils down to 4 key stages. First up is data prep. That's all about gathering and cleaning your information. Step 2 is model training. This is where you use that clean data to actually build the model's brain. Third, you've got deployment, which is just a fancy way of saying you make the model available for people to use. And finally, step 4 is management. You have to keep an eye on it, monitor it, and maintain it over time to make sure it's still performing well.
So, we've covered the what and the how. But building these incredibly powerful tools, it's not just a technical challenge. Not at all. It comes with a huge amount of responsibility.
First on that list is secure AI. This is all about protecting the models and the systems they run on from being attacked or misused. And to help with this, organizations are creating standards, like the Secure AI Framework, or SAFE, to help manage these very, very real risks. And right alongside security, you have ethical AI. This is all about making sure that the AI we build is used in a way that's fair, that's unbiased, and that it doesn't cause harm. It really forces us to ask not just, hey, can we build this, but the much more important question, should we build this?
So there you have it. We've gone from a bunch of confusing buzzwords to the actual building blocks, piecing together the engine that drives modern AI. But now that we understand how it's all built, we're left with this huge, critical question for our future. When an AI creates something completely new, who's actually responsible? Is it the programmer, the person using it, the AI itself? Honestly, that's the next big puzzle we all have to solve. Thanks for tuning in.